Alright, so the second video on modeling, as I said, this one is going to involve solving some story problems. And this first one I already have written up here, so we can just kind of dive into it. The other ones I will write them up here, so it'll take a little bit of time to write them up. But this one is dealing with distance and travel time. We're going to have a couple different types of problems. There's going to be ones involving interest, there's also going to be ones involving proportions, and then also something called mixture problems. Okay, so we'll look at some examples of each of them here. So first off, let's look at this here. You are driving on a Canadian freeway to a town that is 500 kilometers from your home. After 30 minutes, you pass a freeway exit that you know is 500 kilometers from your home. Assuming that you continue at the same constant speed, how long will it take for the entire trip? Alright, now the first thing we should remember here, this is a very important familiar when we're talking about traveling or distance traveled, is that we have distance is equal to rate times time. So this, of course, as I said, distance is equal to rate times time. Now, we have to make sure that our rate and time are in the same units. And what do I mean by that? Well, if my rate is, for instance, that's how fast you're going, if you're in kilometers per hour, your time needs to be in hours. If your rate is in kilometers per minute, your time needs to be in minutes. Alright, so let's look at what we have here. Well, we know that the total distance traveled is 500 kilometers. And that's just given in the problem. So what do I know here? I know then that 500 kilometers is equal to my rate times my time. Now, of course, I want to figure out what time is. That's what the problem's asking me for. How long will it take? So I want to solve for t. So we want to solve for t. But the problem we have right now is we have still another unknown variable. We don't know the rate. So don't know r. So we can't solve for t. Alright, well, let's look at our story problem. The next piece of information here that they gave us that says that after 30 minutes, you pass a freeway exit that you know is 50 kilometers from your home. Well, that is giving me a rate, or a way to get a rate here. So if I have traveled 50 kilometers, and instead of saying 30 minutes, I'm going to say in 0.5 hours, our rate is 50 kilometers divided by 0.5 hours, which would be 100 kilometers per hour. Now, the other thing it tells us is that we're assuming that we're continuing at that same speed. So we're always going 100 kilometers per hour. Well, now we know my rate. My rate is 100 kilometers per hour. So I have 500 kilometers is equal to 100 kilometers per hour times t. And then a lot of these problems, once you have the equation written down, the actual solving is pretty straightforward. We just divide both sides by 100, and we get t is equal to 5 hours. Now, on all of these, there's most likely going to be a unit. You want to make sure to put the unit with your problem. You don't want to lose points on an exam for a silly mistake like that. Alright, so let's look at another one here. So let's look at this one here. So we're going to start off with you measure the shadow cast by 1 Liberty Place and that's located in Philadelphia, and find it to be 105 feet long. Then you measure the shadow of a 2-meter I'm sorry, not 2-meter. I was copying the problem wrong. Come on. There we go. I'm like, why aren't you erasing here? It's not 2 meters, it's 3 feet. Post. And find it measures 4 inches. Determine the height of the building. Sorry, my hands are messing this up here. Alright, so what do we have here? Well, these types of problems here are dealing with what are called ratios or proportions. So we've got a building here, and I'm not going to draw this to scale. So we've got some building here, and it's casting a shadow. So the sun is up here, you know, and it's casting a shadow, and the shadow here is, so this is the shadow of the building, and I'll make it a little bit shorter. It's not the size of the building. And the shadow that it cast is 105 feet. And we're wanting to know the height of the building. Then we have, and these aren't in the same area that necessarily, they're in the same area, but they're not necessarily like right next to each other. Then you have a little post here that's 2 feet, and it casts a shadow that is, I'm sorry, not 2 feet, this is 3 feet, and it casts a shadow of 4 inches. Now you want to make sure everything's in the same units here. So 4 inches is the same thing as 4 over 12 feet, which is 1/3 of a foot. Alright, now when we say these are a ratio, these are in proportion, is that if we take the ratio of these terms here, they'll be equal to each other. And what do I mean by take the ratio of the terms? Well, we have the height of the building over shadow length of building is equal to the height of the post over the shadow length of post. So if I do that here, well, I have the height of the building is h, that's what I don't know, over 105 feet is equal to the height of the post, which is 3 over 1/3. Now, of course, doing complex fractions, you'd get h over 105 is equal to 9. because you would flip that 1/3 and multiply by it, so you'd have 3 times 3. And then to solve this, well, you simply say h is equal to, well, multiplying both sides by 9, you'd have 105 times 9. And then if we multiply this out, you get h is equal to 945 feet. And again, remember to put units on it. All right, so let's look at one last one here. We're going to look at a mixture one to finish this off. Now, mixture is kind of a generic name. It's not literally necessarily a mixture of things. It could be a mixture of, for instance, investment in one account at a particular interest and another account at a different interest. It could be a mixture of inventory, like you might have so many trees of one type or trees of another type, which is the one we're going to look at here. So what we have here is a nursery has $40,000 of inventory in dogwood and red maple trees. The profit on the dogwood tree is 25%. And the profit on the red maple is 17%. The total profit is 20%. How much was invested in each type of tree? Okay, so what is this saying here? Well, this, as I said, is a mixture problem because we know the total profit is 20%. And when we say total profit is 20%, this is just a simple interest. We invested $40,000 in trees. My total profit is 20%. So my total profit is simply 40,000 times 20%, which is, of course, 40,000 times 0.2, because 20% as a decimal is equal to 0.2. So 40,000 times 0.2 would be 8,000. So that's my total profit. But I want to know how much I've invested in each tree. Well, what do we have here? We have that the total profit is going to equal the profit of dogwood plus the profit of red maple. That's where the mixture part of this problem comes from. My total profit is a mixture of profit from my dogwood plus profit of my red maple. Now, what do we have here? Well, the book, if you look at the book here, probably often tries to have you do this without writing two equations down. I like writing two equations down. I think it's a little bit easier personally. So I'm going to just let D be the profit of dogwood, and let R be the profit of red maple. So what's nice about this is we can go ahead, we know what the total profit is. The total profit is $8,000 is equal to, well, profit of the dogwood, let's scroll back up here. Profit of the dogwood is 25%, so this would be 0.25, because that's what 25% is as a decimal, times D, plus, and then the profit of the red maple was 17%, so 0.17 times R. Now, actually these aren't, I shouldn't say profit here, these are investment. Sorry about that. These are investments. What we have here, these are the profits. So let me go ahead and back this up, and I'll just erase this and rewrite it down, because I mean, what our equation is correct, but I want to make sure the terminology is correct here. Okay, so the total profit is profit of dogwood plus profit of red maple. So what do we have here? I'm going to let D be the amount, not profit, but it's the amount invested in dogwood. And I'm going to let R be the amount invested in red maple. So it's just, instead of being the profit, it's the amount. Now what we're going to do is we're going to compute the profit. So really what I should write here is the profit for the dogwoods would be 0.25 times D is the profit from dogwood, and 0.17 times R is the profit from red maple. Alright, and then we'd still get the same thing here. Total profit is 8,000, and that's going to be 0.25 D plus 0.17 R. And again, this is why it's called a mixture problem. The total profit is a mixture of the profit from the dogwood plus the profit from the red maple. Alright, but now the problem is we have an equation that we're trying to solve, either for D or R. I need to know both numbers here, but I don't have a way to solve this because there's two unknowns. But we also know that we have a total invested is $40,000. So what does that mean? Well, if the total amount that I've invested is $40,000, that means I have D plus R is equal to 40,000. Now, you can solve for either one here, it doesn't matter. I'll just solve for R, means that R is equal to 40,000 minus D. Well, now I can take this expression right here and substitute it in right here. So if I do that, you get 8,000 is equal to 0.25 D plus 0.17 times 40,000 minus D. Now I have an equation with one unknown, and I can just go ahead and solve this equation. So let's go ahead and multiply everything out. So you have 8,000 is equal to 0.25 D plus 0.17 times 40,000, which is 6,800, minus 0.17d. So you'd have 8,000 is equal to 0.25 minus 0.17 is 0.08d plus 6,800. Subtracting 6,800 from both sides, you get 1,200 is equal to 0.08d. And then dividing both sides by 0.08, you get that d is equal to 15,000. Now we need to make sure to answer the question. It's wanting to know how much was invested in the redwoods and how much was invested in the red maple and in the dogwood. So R would simply be 40,000 minus 15,000, which is 25,000. So we can now answer the question. Invested in dogwood is $15,000, and then invested in red maple is $25,000. So make sure to answer the question on these. Now, I'm not going to do any more of these. Honestly, the best way to get good at story problems is just doing more and more of them. There's a couple online that you can work on. I would also encourage you just to look in your book to find story problems related to this. And the story problems related to this will help, again, getting this well. And most textbooks, I believe this one does as well, have the odd answers in the book. So the more practice you can do on the story problems, the better you're going to get.